So first off, final questions on PA1.
How does mine look?
Haven't looked at it. Well, I looked at it before and it looked great. So I will start grading those this afternoon, and I'll get them graded sometime this weekend, hopefully sooner rather than later, because I have a new 3D printer showing up tomorrow. So, yay. But I'll definitely get them graded sometime this weekend, and then we'll talk Monday about specifics. If I see recurring things that I feel should be talked about, we'll go over those in class Monday. But I'm really, hoping / anticipating everybody nailed this, because everybody that I worked with seemed like they were on the right track, and so I expect good stuff out of that. So let's talk about PA2. So PA2 opened last night. It's due in 2 weeks. And it's a revisiting of the word index problem that you did from 224. In 224, that was probably a pretty painful exercise. Lots of different parts and pieces to it, lots of details, right? And it's going to probably feel very different in this course, because that's the kind of assignment that really should be done in an object-oriented framework. And we didn't have objects there. We had C. It's basically, bearskins and stone knives. Now we've got more advanced machinery. We've got the whole object-oriented setup. We've got classes, and hopefully you're going to notice a difference in doing this assignment in Java, because we can really bundle things in ways that are logical. And I think you'll find it's more like taking pieces and putting them together, instead of trying to sort of reinvent these fundamental pieces from the ground up. So, as usual, I've written a lot of words here, and I'm walking a line between, if I don't say enough, sometimes people, instead of asking for clarification, will make assumptions, and if they don't make the right assumptions, they do the assignment wrong. If I say too much, nobody will read it, because it's 50 pages. So I'm trying to find a balance here. But I'm going to talk you through this today and tell you everything that I think you need to know about this, and it's a really good time to ask questions about it up front, rather than a week down the road finding out that you misunderstood something fundamental about the requirements. So the goal is to be able to read in lines of text from standard in, and basically produce an index that lists all the words in the input and where they occurred. Okay, where they occurred is just going to be the word number starting from 1, 2, 3, and the words are just going to be alphabetized. And really, really simple input rules. We're going to ignore digits, punctuation, special characters. We're only going to pay attention to 2 things, letters and whitespace. So whitespace is a space, multiple spaces, tabs, new lines, all of that stuff. And letters are just A through Z, uppercase, lowercase. And we're going to change all the letters to lowercase, so we'll pretend everything is just lowercase words. And then we'll go ahead and do our indexing. So let me show you an example. So here's a set of input. It's got 4 lines. And we're going to ignore the commas, the period, the exclamation marks, parentheses, underscore, everything goes lowercase. So here's what the words are that we actually see. The word hello is in position 1. This is in position 2. Is in 3. Is 4. Test is 5. This also occurs in position 6. Is occurs in position 7, and so on. So you're basically going to read through your input. You're going to break it into these words, clean them up, make them lowercase, keep track of your position. Just keep incrementing a counter, so that this is where all the words occur. And then you're going to gather them together and say hello occurred in positions 1, 11, this in 2 and 6, is in 3, 7, and so on and so forth. And then you're going to take that and alphabetize it by word, and this would be the final output. If that was your input, those 4 lines, this is what your main program would produce. So everybody clear on like the behavior, the top level behavior of this? All right, so I'm going to make a statement that's a little counterintuitive here, and I've said things like this before. It definitely applies here. So for the sake of getting a grade, for assessing you on this assignment, you obviously want to get a program that produces the correct output, right? That is not the real benefit of this assignment, though. The real benefit of this is the process of getting there. And if you sit down 2 days before and you do this 15-hour marathon coding session and you come up with something that produces perfect output, you might get 100%. You may not have gotten the real benefit from the assignment. The real benefit is the process of building this up, starting with a simple version of this, adding more details to it, and as you do that, thinking about objects, thinking about, I want a linked list here. Should I write 80 lines of code for a linked list? No, I'm going to take a separate class that implements a linked list. I'm just going to plug one of those in here. Now I need to traverse that list. Should I write some code that goes through the list node by node and prints it out? No, I'm just going to use a method in that objects class. Okay, so we really want to keep coming back to the idea of, are we doing object-oriented things or are we writing C code in Java? Because you can write C code and you can get the result. But try to lean on the object-orientedness, the classes, the whole structure that brings to us. And it will generally make your coding life a whole lot more pleasant. Because it really lets you focus on, right now, I just want to get this one thing working. And you can push those other details aside. That's going to be handled by this class or that class. So we'll look at a specific set of steps that you can take to get from here to there. Punchline, you're going to build a linked list of linked lists. So I've threatened this for 3 quarters now as a thing. It is a thing, okay? It's going to be a linked list of words. So each word that you find in your index is going to be a node. It's going to point to another node. So your usual linked list of strings, which we implemented a few days ago, right? But there's going to be another piece of information in each node. There's going to be the word. There's going to be the pointer to the next node. But there's also going to be something that tells you all the places where that word is located. So when you see the word is, somewhere there's going to be something in that node that points to something that has a 3 and a 7 to tell us those are where the word is occurred. And that thing that it's going to point to that has those numbers in it, that's just going to be another linked list. But it's going to be no harder from just having an integer or a string or a character. It's just going to be a blah, where blah is a class that holds a linked list. All right, so it says we'll draw some pictures in class. That's what's happening next. So let me show you a picture of this first, and then we'll look at details. So I'm just going to write my input. I'm going to assume you've already pre-processed it. And it's all lowercase and there's no punctuation. So there's 6 words of input. This is fun, is it fun? So here's what your final list is going to look like. Let's see if I can alphabetize in my head. Here's our first word. Second word, so this is a plain old linked list of strings. Four nodes. Last node points to null, so that's the end of the list. And this third field down here actually points to a linked list. So these are word positions 1 through 6. So fun occurs at location 3 and at location 6, and this is null. Is points to a little linked list that says is at location 2 and it's at location 4, and that's null. And it points to a linked list with a single node, which is location 5. And this is a single node with location 1. So that's the data structure you're ultimately building. And we have in this structure all the information we need to print out a word index. the words are alphabetized, so if we start with the first node and we print out the word, we see that the word fun is somewhere in our input. And then if we print it out 3 followed by 6, there's the locations. Go to the next word is, print out the 2 and the 4, that's those locations, and so on. Now there's going to be a class for this whole list, where we're going to call a word list. There's going to be a class for each of these lists of locations that's going to be called a location list. There's going to be a class for each node in the word list, that's like a word list node. A class for each node in the location list, that's a location list node. And there may be some other classes you want to build up. But now, for example, suppose you are traversing, let's say this is WL, suppose that's the name of my word list. And I want to go through and I want to print my index. So I could do something like temp equals word list. Well, temp is not null. And this is sort of pseudocode. Well, what do I want to do? I want to print out temp.word. So we'll do system.out.println temp.word. And maybe I'm going to put a colon after that. And then I want to print out the list of locations. Okay, let me give you an imaginary node structure. So there's a word, there's a next, and there's a location list. So I print out the current word. I print a colon after it. And then I need to go into this list. I need to find the first node, print out its data, see if it points to something. If it does, move to that node, print out its data, do a little loop, right? But this whole thing is a location list. And I might write a toString method in my location list. And it would let me do the following. Print out temp.word plus a colon plus location list. And then move on to the next node. There's your whole traverse program. And it's going to produce beautiful output. Because in my location list I have a toString method that prints out the first node, adds a comma if it's not at the end, followed by a space, and so on and so forth. But that's all bundled inside here. Sorry, this is actually temp.locationList. That's the punchline. So at the point where I'm trying to traverse my word list, I don't need to deal with the details of how do I print out the nodes in the location list. I just add the location list to my output. Okay, that's the kind of thing you want to keep coming back to. So you should never really find like a set of code that's too complex. You shouldn't have too many excuses for nested loops or very complex nested conditionals or things like that. A lot of these behaviors you just push off into other classes. Now where does this toString method come from? You have to write it, right? But when you're writing your location list, you're not thinking about words, uppercase, punctuation, PA2, all that stuff. You're just, I'm going to make a list of integers. I'm going to have a way to add to the end. I'm going to have a toString method. And you've done this before, right? You made linked lists multiple times in 222. You added to the end of lists when you implemented queues. And you're going to port it to Java. Well, Java looks like C. So that piece, not too bad. And in fact, none of the pieces should be too bad. It's really sort of designing the pieces in a way that they fit together and then putting them together. All right, so list of lists, make some sense initially?
Yes.
Okay. So let's look at how you're going to implement this. What are the required classes here? So location list is just a linked list of integers. Nothing fancy going on there. but I still want you to implement it as its own class called location list, uppercase L's. Word list is sort of the main structure. Word list is this whole thing, right? So it's a collection of these nodes that have a string, a pointer to a next node, and also a piece that's a location list. So word list is basically a linked list of words, but each node has three pieces. So there's the word itself, there's the pointer to the next node in word list, and then there's the location list. All right, third class you're required to implement is called index utility. And this is the class that you interact with from the main program to make your program do its thing. So it has a single method called build index. So you construct an index utility, and then when you say build index, it'll read from standard in, pre-process the text, break it into words, build up your data structures, and then return. And then you can use a print method in your word list to actually look at the contents. Okay, so more details on the class's location list. Takes no arguments to construct, do whatever initialization you need. If you want to use sentinels, you can, you don't need them. Okay, but if you wanted to use a sentinel, you could construct that in your constructor. And you only need one method in here, which is add to end. So add to end takes an integer, creates a new node, tacks it on the end of the linked list. But if you want to put a toString method in here, that's going to make your life nicer. Or a traverse, or whatever else you like. So this is bare minimum requirements. You can always add extra things to your classes. Okay, word list class has two methods. Add word, which you feed a word and a location where that word appears in your input, and it updates all of those data structures to record that word in that new location. And then print just goes ahead, moves through the list, prints out the nice output. So word followed by comma separated list of locations, space separated list. All right, an index utility just has the build index method. So if you put those together, there's your entire main program. It's 3 lines of Java. Construct an index utility, call the build index, take the return value, save that in a mylist, and then call mylist print method. And those 3 lines, if you build these classes correctly, will do all of that magic. Read the input, pre-process, convert, tokenize, tally it up, count it, and then print it out in alphabetized order. Right? And this is the epitome of object-oriented design and usage. Right? 3 lines of code, and we get all that stuff happening. And all that magic is really happening in the second line. Right? And in fact, we don't even need to do this in 3 lines. We could do this in 1 line. We could do new index utility dot build index dot print. But we'll splurge and use 3 lines. All right, so you can use this code verbatim if you want to test your classes. But in practice, we're going to build this up from small pieces to larger. Okay, additional details. Definitely implement the linked list classes yourself. There are linked lists provided as part of Java. You're not allowed to use those. Okay, that's the whole exercise here, is creating your own linked list classes. On the other hand, strings, characters, scanners, all of these classes have lots of useful things in them that you should feel free and encouraged to use. If you want to know if something's a letter, don't try to turn it into an ASCII code and compare it to a range. There's an isLetter method in the character class. So we'll look at some of those in detail, but you really want to sort of get familiar with particularly the string class, the scanner class, a little bit of the character class, and let those do as much of the work as you can. So that your job is the programmer. You're putting together the pieces, right? You're not inventing the screwdriver and the screw. You're inventing the rocket ship, right? And you're using these things just to build this up together. Sentinel nodes, up to you. You'll also need to define classes for the nodes themselves. Okay, because there are different types of nodes. Integer nodes in the location list are different from these 3-part nodes in the word list. Keep an object-oriented mindset, I keep saying that. Be modular, develop it in pieces. We'll talk about a suggested approach next. Be really sure that you understand completely every line of code that you write. Okay? If you find yourself writing a line of code and you're not quite sure about it, ask yourself this: could a guy go up to a stranger on the street and explain to them like what this line of code does, why I put this in my program? Somebody who knows nothing about programming. Could I like give them some convincing argument for what's going on here? So if you go online and you find some way to do something and put the keyword static here or add extra brackets on there, make sure it makes sense to you. And if not, either post a discussion question on Canvas and say, hey, I found this thing. Anybody else use this? Anybody know what it means? Or shoot an email or ask in class or office or something like that. Okay. And it can be a really fun assignment, right? Most programmers, there's a certain happiness that comes when your program works, right? And this one has a lot of little points along the way where you've got some piece you're working on and you get it to work and it's going to feel good. And because it's object oriented, you can take that piece and you can wrap it up in pretty paper and put it on a shelf and it's done. And you can look at it, but you never have to go inside it again, right? Assuming that you know how to use it and you've documented it and you've tested it, that's a finished product right there. And you're not going to have to go back into the code and tweak it and think about this again and that kind of stuff, right? So we get lots of these little successes along the way to completing the larger project. If you go about this in kind of a methodical, modular way. So I thought about this the other day and I came up with like an 8-step approach to go from beginning to completing PA2. And you're not required to follow this. And you can follow part of this until you see a clear pathway to the finish, and then you can follow that pathway. You can follow this completely, you can totally ignore it. It's up to you. This is just a suggestion of a way that you could begin with smaller pieces and build on top of those to make larger and larger pieces until you get to PA2. So if any of this works for you, that's fine. If not, don't worry about it. It's totally optional. But here's one way that I might go about breaking this into pieces. So step 1, I would just begin by trying to write something that just reads in words. So what is a word in this sense? Ultimately, a word is, lowercase hello. We ignore the comma. Test without the period. Fun, lowercase, no exclamation marks. Good, bye, with no underscore in the middle and a lowercase g. So ultimately we want to be ignoring punctuation and so on and so forth. But to begin with, just try to read things that are separated by white space. So if it's hello, comma, space, just read in the word hello, comma. Yeah?
So with the symbol in the middle, goodbye would be counted as one word.
One word, yeah. Because before you do anything else, ignore all those other symbols. And then go ahead and say, okay, what's a word? So first task, just read in things separated by white space. So there's the scanner class. And it comes in Java util scanner. And I'm free of the internet now because I downloaded all the documentation that's on my hard drive and I wrote a front end to it. So we won't get stuck with that. So Java util scanner, so you have to import this. And there's a ton of methods in here, but the main one to look at is this Hasnext. So Hasnext returns a Boolean and it says, is there another token in its input? So token is a general word for just a chunk of input. Okay, and what defines a chunk? Well, there's lots of rules we can use for that. So if you look at next, a complete token is preceded by input that matches the delimiter pattern. Preceded and followed. And the default delimiter pattern is white space. So if you have a bunch of input, anything that's preceded by white space and followed by white space, that's a token. And Hasnext will say, is there a token ready to be read? And if it returns true, then the next method will return as a string that next token. So tokenizing your input is no harder than just repeatedly calling this next method in a scanner object. So let's try this. So import that because that's how the system knows where the scanner is located. Class name has to match your file name. Public static void main. You'll be saying it in your sleep. So let's make a temporary string.
I noticed it didn't accept main without something inside its parentheses.
Yeah, you gotta have the arguments there too.
Oh, by the way, I think ours is misspelled.
It is, and that's actually okay. Because it doesn't care what I name the variable. But do you remember what the signature of a method is? What are the pieces of a signature?
Whatever it identifies as and what it's using.
Right. So what it identifies as? So the name of the method and the types of arguments that it takes. Okay? And the name of the arguments, that's pretty arbitrary. But if I have a main that takes an array of strings, the system looks at that and says, that's your main program. If I have a main that takes a single string, that's just a random method. And it's not going to see that as my main. All right, so go ahead and construct a scanner off of system in that gets you through standard in. And then check the Hasnext method. That says, is there a token available? If there is, go ahead and use the next method. To read the next token, save it into temp. And I'm just going to print that out inside angle brackets.
You don't have Ellen. You have printing.
I have printing. Thank you. And then I'll just print out a message at the end saying we're done with the input. Close the scanner. And there's a test program.
The second print.
Print new line. This is great because I never have to compile. Because you people catch all my errors. This is awesome. All right, does it look good? So, two methods. Scanner Hasnext, scanner next. But this will do a lot of work for you.
My class.
How about my scan? So you put the input, this is a test, and it says this is a test.
Woohoo.
And so you can double check how it's breaking this thing into tokens, and sure enough, it seems to be breaking things at the spaces. And the spaces are just delimiters. So if you have extra spaces, it's not going to change anything. It's just going to break up the things before from the things after. And then Control D for end of file, and that causes SC Hasnext to return a false, and you kick out of your loop. Now to do this in C, unpleasant. Lots of work. Right, lots of manipulating arrays and strings and calling fgets and scanf and pointer adjustments and things like that. That's what's going on inside Hasnext and Next. All right, and we don't have to look at that code. We get to just use it. So you want that same kind of mindset as you develop the other pieces of your code. Okay, so that could be step one. Tokenize and print out. Step two, add a counter. Well, that's not too hard. Have a counter, initialize it to 1. Every time you get a new word, print out the word followed by the counter, and then increment the counter. But now you've got a big piece of PA2 working already. You're finding the position of each word. So run that. You should get a list of words with a number next to them. The numbers keep increasing. Okay, step 3, clean up the input. So when you get this stuff coming in, it's got punctuation in it, and it's got uppercase, and so on. So write a method to clean that up. And this has nothing to do with scanners or PA2 or anything else. Just write a method that takes a string, gives you back a string. But what does it do in between? It takes the string, it eliminates all the punctuation, it converts everything to lowercase. So how do you do that? Well, make yourself an output string. Start it off as empty. Go through your input character by character. Check to see if it's a letter. If it is, concatenate it to the output string. And while you're at it, turn it into lowercase. When you're done, you've gone through the whole input, your output string is your cleaned up input. So you can write that method, you can test it, you can convince yourself that it works, and then tie that into what you did in step 2. So now you get a list of cleaned up words, pre-processed words, with their location next to them. And a little note here, if you have a word in your input that only contains non-letters, it'll convert to an empty string. Don't worry about that for now. Eventually we'll just ignore those. We won't add them to the index. But for this step, it's fine. So what can help you with this? So the character class has a ton of useful things in it. It's got one method in particular, which is called isLetter. And isLetter, you give it a character, it tells you is it a letter or not. So put that right into your if statement, and that tells you whether or not you want to append your character to the output. So we're going to talk about static either later today or Monday. This says public static boolean isLetter. Okay, when you see the word static in Java documentation like this, here's what it means. If you want to know if something is a letter, you type in the name of the class, period, and then the name of the method, and then you pass it whatever argument you want. Static means that you're allowed to refer to this method by typing in the class name followed by a period. Most methods we have to type in the name of an object followed by a period, followed by a method or a field. But statics, we can just type in the class name. And this is the same thing as when we do math.py. We're accessing this as a static piece of this class.
This is like C, just calling a function.
Yeah. So we'll break that into more detail on later today or Monday. But if you want to use this method, it's called character.isLetter, just like character.getType. So how do we get to that particular character in our input string? Well, look at the string class. And once you read in that token, call it temp or whatever, right? Temp has all these methods available, including a method called character@. So you could say temp.character@5, and it gives you the 5th character. That returns a character. That's what you can put into character.isLetter. So you can tie all these pieces together. So make a for loop, go from I equals 0 to temp.length -1. Grab the character at index I, see if it's a letter. If it is, concatenate it to the output. And while you're at it, we have a 2 lowercase, which takes a string and gives you back the lowercase version. So after you build your output string for your token, you can turn it into lowercase, or you can turn it into lowercase first. Or if you want, you could do it letter by letter. All right, still with me? All right, so now you're tokenizing, you're cleaning up the input, you're printing out the location of each word after it appears. Now start making your first linked list. This is your word list. And for starters, let's just make a really simplified version of our word list, where our nodes look like this. Here's a word. Here's an integer location. And here's a pointer to another node. Same old linked list you've always done, but it has an extra data field, which is just an integer. And what you're going to do is you're going to store each word that you read from the input in a node of your linked list. You're going to store the word, store the location. Take the next word, store the location, and so on. So yeah, the locations will be sequential, but that's okay. You're building up a structure that you can use more generally. And for starters, just add to the beginning of the list, because that's the easiest thing to do. You know where the first node is, just create a new node, point to the old first node. Remember that as your new first node. So for a first version, add to the beginning of the list, and then write a method for traversing and printing out the location and word. So go through each node, print out the word, print out the location. And what you should get from here is the exact same thing you got from 3, but it'll be in reverse order, because you're inserting at the beginning of the list, so you're going to traverse in the opposite order. Okay, step 5, do the same thing, but now modify it so that you're adding to the end of the list. So when you get your next word from your input, tack it onto the right side of your list. And that's your queue implementation using a linked list again. Slightly more work, but incrementally, pretty small step, because now instead of just inserting in the beginning, you follow through until you get to a node that points to null, and you have that point to your new node. Okay, but so far these pieces, you can do these in a fairly short amount of time. They're kind of like ODP level tasks, which means that if you're familiar with the problem space, you can probably do these in like 15-20 minutes. If not, it might take you a few hours, and that's a good thing because it means you're learning something fundamental there. Right, so that's time well spent. And once you finish step 3, right, then you're in a good spot to go on to step 4 and so on. Okay, so 5, we're adding to the end of the list. Now your output matches step 3 exactly. Step 6, this is the real sort of jump to almost the complete PA2. So step 6, we're going to make one change to the node structure. Instead of being an integer location, this is going to be an array of integers. And since we have an array, we need to know how many things have we stored in that array, so we're going to add another field here, which is going to be something like array size, to tell us how many things we've stored. So make this array something big, 10, 100, something big enough for your test case, just a fixed size, and start off the first time you store something, set array size to 1. Next time set it to 2, and so on and so forth. And you can use that to figure out where to store the next number in your array. But once you have that, you can make almost a whole PA2. So what do? We do the same thing as in the previous step, but when you get a word, instead of just adding it to the beginning or the end of the linked list, traverse the list and look for that word. So use your .equals method from the string class. And if you find that word somewhere, instead of making a new node, just save that location in the next spot in this array. So use the array size to figure out where to store the next integer, store it in that array, increment array size. And now when you're done, you've got a structure that has all of the essential pieces. It's not implemented with a list of lists, and it's not alphabetized, but we can go through, we can find each word, and in that array we can find all the locations where it's stored. So if you traverse that and print it out, you should get the same information as what you have up here in this sample output. And once you get that, you're in the home stretch. All right, step 7, change from an array of integers to a linked list of integers. And if you implement the location list class first, this is like one line of code you have to change. You're actually going to end up deleting code because it's simpler to use a linked list. And all you do is you change this from being an integer bracket location to being a location list. You've got an add to end method, so you do that thing where you say variable.locationList.add-to-end, give it the location you want to add, and you're done. It tacks it onto the list. That was step 8 I just said. Step 7 was making the location list class. So step 8, you plug that in instead of the array. And then you're basically done. So then it's cleanup and final detailing at that point. So change your insertion of a word so that as you move through, if you want to insert the word, igloo, you come here, it comes after fun, it comes before is, so you sandwich it in between these two. So do your thing with the previous current node, move those in lockstep till you find where you want to insert it, and then adjust the previous pointer. Use the following pointer to update your new node. Same thing that you do with linked lists that you keep in sorted order. So make that tweak to put your words in alphabetical order. Bundle your traversal code into a print method. Add your comments if you haven't been commenting as you go. This is a really good reason to comment as you go, because you want to take this thing and you want to bundle it up and not have to think about it again. So leave yourself comments to remind you how to use this. Bundle it together, make sure you've got your name on it, do some final testing, put it in a tar file, upload it, you're done. And as I say, you don't have to follow each of these steps. Chances are, right, if you know how to start, go ahead and start. If you're not sure how to start with step 1, right? Tokenize your input. And chances are, as you go, at some point, you'll see, oh, wait, I know how to do this from here. You just go off and finish it however you like. But this is another reason why you don't want to leave this until next week to begin, right? You got 2 weeks. If you start this weekend, and you finish it Sunday afternoon, that's a good problem to have, because then you got a week and a half off, right? But if you started this weekend and you realize you have no idea how to implement a linked list in Java, well, you can come to class Monday, and when I say any questions, you can say, how do you do a linked list in Java? And we'll work around that. So start it early, right? Not just because I like saying that, but because there could be a lot of work here, depending on how comfortable you are, how well internalized these concepts are. And if they're not pretty solid in you, they will become much more solid after you've done this. So leave yourself time for these things to sit in your brain and gel. All right, so submission, pa2.tar, put in all of your Java files. I'm going to update this and say don't include your main.java. I just want those classes that are described. Keep working on the command line. Okay, I would still say stay away from Eclipse, IntelliJ, so on at this point, because you still want to get the practice of, public static void main parentheses string bracket bracket, so that when it comes to doing a test or a job interview or whatever, these things are second nature to you. We'll move to using IDEs with the next programming assignment, because we're going to be using things that need 20 imports, and we don't want to have to type all of that in every time. But the stuff you're doing here, this is stuff that you want to make sure you're pretty comfortable with doing from your head. So stick to the command line, make sure your code works on the Linux server, and then put it in pa2.tar and upload that. Yeah. Yes.
Do we also need to import the character class, or is that already imported?
Character should be available. Scanner has to be imported. And I don't know if there's an easy way to know that. So java.language, I think that's already available. But scanner is java.util.scanner, like utilities, and that has to be brought in. And if you forget to import, it'll just tell you, I don't know what this thing is. And that's your clue that you have to import it. All right, other questions on that? You can probably make significant progress on PA2 in a lot less time than I just spent talking about it. And if anything's not clear, definitely ask or post on Canvas, right? My intent with most of these details is to eliminate the weird edge cases that you might get bogged down on. So if there's something that you think is going to take you 50 days to do, right, it may be an edge case that you don't need to worry about. So always feel free to ask. All right, let's see if I have a net connection. I do. So we're not doing one-day programs this quarter, and I've had some people come up to me and ask about practice problems that they can be using in place of the ODPs. So I don't know a lot about this, but I did some looking around and I found this site, and it looks pretty good. Okay, so it's called W3 Resource. And no personal connection to me, no serious experience with it, so if it's terrible, if it's got errors in it, sorry, okay? But from what I've seen, it looks like a reasonable place to go and get some practice problems to work on. So you can go to Exercises with Online Editor, and there's a section for Java. And if you click on that, there's different categories. So let's say you want practice with conditional statements. So there's just some exercises here. Write a Java program that accepts 2 floating point numbers and checks whether they are the same up to 2 decimal places. And that's the kind of thing that I was typically doing with one-day programs. Just sort of things that might not take a lot of time if you understand the principles involved, but if you don't understand the principles, it's a useful way to sort of figure those things out. Take 3 numbers from the user and print the greatest number. I think that was a midterm question once in 224. And so for these, you can say go to editor, and it gives you your stub of a program, and you can type your code in here, and you can hit the run button, and it will execute it for you and show you any output. And there's no output produced here, right? But it's a nice little test environment for actually working with this stuff. And if you totally give up and you want to see the solution, you can see solutions. And it will show you sample usage, and there's some sort of picture. I want that to be an elephant, but I don't think it is. Some sort of picture of what's going on. And then there's the Java code that would implement this. So they're using a scanner, and they're using next int, and so on. And guess what? They even have flowcharts. So that's bonus. So, looking at the algorithm devoid of the specific code, what is the set of steps that we follow to perform this task? And then you can go ahead and you can put code in down here and mess with it and so on. So that seems to me like it could be a useful resource. So see how that goes, and if you have feedback on it, definitely let me know. Because if this seems useful, I'll recommend it more in the future and put it on Canvas and such. As far as I can tell, it's free, other than incentives to buy CenturyLink internet on the side. But see how that works. All right, good. Awesome. All right, have a great weekend. I will see you on Monday. We'll talk about statics in detail then.